Welcome to Build Your Own Tiny Database Engine, an autism-friendly coding tutorial where we'll build a tiny database from scratch step by step using plain JavaScript and Node.js. By the end of this video, you'll understand what tables, rows, queries, and persistence actually are underneath the abstraction layers. No rushing, no jargon, just calm, clear explanations. Before we build anything, let's look at the finished result. Our tiny database can insert rows, search through stored data, and even save everything to disk so the data survives after the application restarts. This is obviously much simpler than something like PostgreSQL or MySQL, but the core ideas are surprisingly similar. Now that you've seen the finished database working, let's build the file that makes it happen. Start by creating a new file called app.js. This file will hold our entire tiny database engine. At the top, we import Node's built-in file system module using require. This gives us the tools we need to read and write files on disk. Next, we create a variable called database_file and set it equal to database.json. That tells our app where the database will be saved. Then we create our users table by calling load_database. This means the app starts by checking for saved data. If data already exists, it loads it. If not, it starts with an empty table. Now we define load_database. First, it checks whether database.json exists. If the file does not exist yet, the function returns an empty array. If the file does exist, the app reads the file as text. Then it checks whether the file is empty. An empty file should also give us an empty table. Finally, JSON.parse converts the saved JSON text back into JavaScript objects. Next, we define saveDatabase. This function converts our users table into formatted JSON and writes it into database.json. This is the part that gives our tiny database persistence. Now we define insertUser. This function receives a user object, creates a new row, gives that row an ID, adds the row to the users table, saves the updated table to disk, and returns the new row. So now our app can create a table, load saved data, save new data, and insert new rows. Now let's finish building our tiny database engine. The first thing we're adding in this section is the findUserBy function. This function allows us to search our database. It accepts two pieces of information, the field we want to search and the value we're looking for. Inside the function, we use filter to look through every row in the users table. For each user, we check whether the requested field matches the requested value. If it does, that row is included in the results. This is one of the most important concepts in databases. A query is really just a way of asking questions about stored data. In our case, we're asking questions like, find all users whose name is Alice. Real databases use sophisticated optimizations to answer those questions quickly, but the core idea is very similar. Next, we reach the demo section at the bottom of the file. This code runs when the application starts. First, we print a message so we know the database engine is running. Then we insert several users into the database using insertUser. Each time we call insertUser, a new row is added to the users table and automatically saved to disk. Next, we print all users so we can see the current contents of the database. After that, we perform a query using findUserBy. In this example, we are searching for a user named Alice. The function returns every matching row, and we print those results to the console. Finally, we print a message letting us know that the database has been saved to database.json. At this point, our tiny database engine is complete. It can load data from disk, insert new rows, search existing records, and save everything back to disk when changes occur. Pause the video here if you need more time to study the code before we run it. In the next step, we'll execute the application and see our database engine working in real time. Now let's see our tiny database engine in action. Open the terminal in the same folder as app.js and run the command node app.js. The first thing we see is our startup message, confirming that the application is running. Next, the database inserts 3 users, Alice, Bob, and Charlie. Each user becomes a row in our users table, and because insert user automatically calls save database, those rows are immediately written to disk. After that, we print the contents of the entire table. Notice that we can see all 3 user records, including the IDs that were assigned automatically. Next, we test our query function. We're asking the database to find any user whose name is Alice. The findUserBy function searches through the table, finds the matching row, and returns it as the result. Finally, we see a message confirming that the database was saved to database.json. If you look in your project folder, you'll now see that file sitting next to app.js. Open it and you'll find the data stored as JSON. This is the moment where a tiny database becomes persistent. The database isn't just living in memory, it's been written to disk, which means it can survive after the program closes. Try running the application again and watch what happens. Because we're loading data from database.json when the application starts, our tiny database can restore previously saved information. And that's the foundation of what databases do: store information, retrieve information, and keep that information around for later use. Let's quickly recap what we built. We started by creating a tiny database engine using plain JavaScript and Node.js. First, we created a table to hold our data. In our case, that table was simply a JavaScript array. Next, we built the ability to insert rows into that table. Every time we added a user, our database automatically assigned an ID and stored the new record. Then we added querying with the findUserBy function. This allowed us to search through our data and retrieve matching records. After that, we added persistence by saving our table to a JSON file. This meant our data could survive application restarts instead of disappearing when the program ended. Finally, we combined those pieces into a working database engine that can load data, insert records, run queries, and save information back to disk. Even though this is much simpler than a production database system, you've now seen many of the core concepts that real databases are built on, and hopefully databases feel a little less like magic and a little more like software you can understand and build yourself. Right now, our tiny database engine has one major limitation. Whenever we run a query, the database has to look through every single row until it finds a match. That's fine when we have 3 users. It's still fine when we have 100 users. But what happens when we have 1,000,000? Suddenly, every query becomes much more expensive because the database has to keep scanning row after row after row, looking for the information we need. Real databases solve this problem using something called an index. An index is a specialized data structure that helps the database find records much faster without scanning the entire table. It's similar to the index at the back of a book. Instead of reading every page looking for a topic, you jump directly to the pages you need. In our next video, we'll build a tiny database index from scratch so you can see exactly how this works behind the scenes. And just like today's project, we'll keep it simple, visual, and step-by-step. You just built a tiny database engine from scratch, and hopefully databases feel a little less mysterious now. If this kind of direct autism-friendly tutorial is helpful, subscribing is a great way to find your way back here. If you'd like to support this channel, I have additional resources available on Patreon, including coding affirmations and the Autistic Coder reference guide. You can find them at patreon.com/autisticcoder. Thank you for watching, and let's keep learning and growing together.